So if they try to write into the HKLM local machine registry, that may get redirected under the covers to an area that this compartment is allowed to write to. So it's similar from that perspective in that we vastly constrain what the code is allowed to write to, and we constrain what this process is allowed to manipulate beyond things in the file system, for example. So this protected mode process can't even open up and manipulate processes running here, 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 well, or in the kernel.
Yeah, so that's done through a similar SID system you're talking about with the service SID? How do you actually prevent that process from launching another process?
Yeah, so actually in the case of protected mode IE, we did not employ the same identification mechanism. We actually looked at employing the same identification mechanism, and that was something that we were calling an app SID. Instead, what we employed here was something called MIC, mandatory integrity controls, and this is similar in nature in that you get a new SID assigned to this process, and that SID will influence later security decisions, but it's a bit more coarse-grained than a service SID with a write-restricted token. So you can think of a write-restricted token with a service SID as mandatory integrity controls in a compartment. In this particular mode, basically protected mode IE, let's assume for a moment you had another protected mode program. Let's say we enabled another program to run in protected mode. It would have access to IE in this model because it's running in the same environment here. Whereas in the service model, they're really, compartments here potentially where you can have a service here, service 1, service 2 over here, and these can have some level of separation. Whereas with MIC, as used by protected mode IE, if another protected mode program came along in the current model, they would have access to each other in this environment.
So that's because in the limited service scenario, each service has its own unique SID.
Correct.
And so you can ACL things, say this particular service, and it sounds like in the low rights mandatory integrity framework, everybody in that band sort of has the same SID, essentially?
Actually, everybody in this band running is the same user. So if I've got a machine where you and I share the machine, like in a home environment, they're not going to have access to each other's temporary internet files, for example, because the ACL covers both the user and the integrity level of the program that's trying to access that data.
So then how does that actually prevent that guy from launching another process or accessing a directory? Is there a specific deny?
Actually, he can launch another process, but it's just going to inherit the same restrictions. So if the low-rights browser launches another program directly, it'll have the same constraint. So it would only be able to write to the temporary internet files, low-rights folder, for example. It's not going to be able to just go off and then jump over here and start manipulating the user or any of the administrative areas.
Sure. So if I looked at the ACL for a particular folder, say my documents folder, would I see a deny ACE for that SID?
No, you wouldn't see a deny ACE. What you would end up seeing is it depends on whether it's been set explicitly or not. So the default integrity level for everything running here is medium. So medium is the implied integrity level. So in order for him to write to a resource, it actually would have to be labeled as granting low write access. So if you're not granted, if low isn't granted explicit write access, it'll fail. And that's pretty similar to what we talked about with the services. It's just implemented using a more coarse-grained mechanism.
So what happens in IE if you have an ActiveOS control that expects to be able to write something to an area it's no longer allowed to do?
Well, so there is the virtualization layer that I mentioned before, and that's really meant for handling the legitimate
Compatibility.
application case, the compatibility case. In the case where you need to install an ActiveX control, for example, what happens is this browser running here does not have sufficient rights to install the ActiveX control. What he does is he employs what we call a broker, and the broker is actually running in this environment, and there's an LPC mechanism that the browser uses to communicate with the broker to ask it to do things like install an ActiveX control. And then the broker will be responsible for displaying UI to confirm with the user. So the UI would be coming from the broker. It can't really be spoofed from the low rights guy.
But so if I installed a malicious ActiveX control in IE running in protected mode on Vista, that control couldn't do anything. Couldn't install a rootkit.
Correct. Yeah,
Couldn't do anything deadly to me like it can today.
Yeah, so it doesn't have the ability to write into the System32 directory, for example. It doesn't have the ability to call create service, which can be used to get a device driver running. It has very little access to manipulate the system.
Very cool.
Do you worry about the shatter attack across these guys also?
Yeah, so we do, and that's what led to the introduction of a feature called UIPI. And essentially what UIPI does is it implements a policy that says that window messages that originate from a lower integrity level will be blocked from a higher integrity level receiver. So for example, I think there's a message called WM timer that might allow somebody to cause code to be run in another process. So if he tried to send a WM timer message from the protected mode IE into another process running as the user, that attempt would be blocked. And that's keyed off the integrity level in the token. So it's basically a lightweight way to do an access check on a window message. So before Vista, window messages were one of the few resources in the system that they weren't really backed by an object or a call to access check. So we've implemented a very lightweight version of an access check that can be used for that purpose in Vista.
Very cool. Well, this sounds like it's a pretty damn secure system.
I think there's plenty we didn't even touch.
Yeah.
We were going to talk about next gen crypto and Gina stuff, and so maybe that's a topic for another day, huh?
Could be. I mean, depends on how much time you can keep on talking here. But let's see. So what exactly we did? We covered pretty much the basics, though. I mean, yes.
Yeah. So we kind of covered some of the work that's happened here, some of the work that's happened here, and then and here, of course, and then some of the perimeter work here. I think UAC has been pretty well covered in terms of there's a lot of developer documentation out there. There's been a lot of visibility in terms of Microsoft reaching out to ISVs to get them to change their apps. There's a lot of app compat data that we've chased down. That's an area where I think there's a lot more exposure here today. There's not as much exposure in the ecosystem around what we've done in the kernel, except you've heard a lot of press recently around things we might be doing in the kernel. Certainly for Vista RTM, some people have made claims in the press that we're turning off PatchGuard or providing a way to turn it off. That's just not happening.
Okay.
And we have no plan of ever doing that, actually. The approach that we are taking is really identifying what the ISVs were doing that led them to patch the kernel, and then looking at what are the new APIs that we can introduce that allow them to do that without patching the kernel. That's really the focus.
Good. I mean, because in reality, what we talked about from the very beginning of this conversation was the kernel really should be isolated from everybody. But because of the driver model, because of the way you have to write stuff in the kernel, but one day it would be nice where no one will ever have to do anything in the kernel again. I know people are thinking about that in Windows.
Yes. Yeah, and in fact, one of the things I didn't touch on was we have introduced in Vista a new user mode driver framework that allows people to write driver-oriented support software and have it run in user space instead of kernel